This time we're going to go over all those basic charts. And our main tool is Plotly. We started using Plotly last time. And today we're going to get started just by importing the Plotly library again. So the syntax is easy, right? Import plotly.express. So this is the high-level interface for Plotly. I want to be more efficient, so we use the high-level library instead of diving into the very detailed controls on how to use different modules inside Plotly. So we use Plotly Express, which will significantly reduce our workload. And this command imports Plotly. Now, let's create a data frame. Usually, so far, we have been loading data from CSV file or JSON file, and we also talk about how to load data from database, right? And today, let's simplify the matter, in order to save some time. So here, I'm going to use a very simple data set that is already included in the Plotly library. Okay, so px is plotly.express. So let's define a data frame. We're going to call it DF medals because it's about Olympic medals by different countries. And I should mention that this is a hypothetical data set. So what you see in the data set is not the reality. It's just a very overly simplified example, but it still serves the purpose. Okay, so how do we get the data set? Well, px is plotly.express, and it came along some embedded data sets. So px.data, that's referring to the part where the Plotly Express module stores some of the example data sets. Right? And .medals underscore wide, and this function will return a data set about Olympic medals by different countries. This is something we call the white table of the data set. I will see why it's called the white table, because there's another table of the same data set, just in a different format, which is called the long table. Okay, but right now let's not worry about that too much. Let's use this command, and all we need to know is that this command will give us a data frame. And we can, of course, see how the data frame looks like by typing the name of the data frame in the end of the code cell. It's a very small data set, so we don't even need to use anything like the head function to see the first few rows. We can easily see everything. So it will take a few moments for the first command. As we can see, it's just a very, very simplified data frame, right? So it's just a table of 3 rows, right? And 4 columns. First column shows you the countries, and then the remaining 3 rows tell you how many medals in each category is won by those countries, hypothetically in one Olympic Games. Okay, so let's say South Korea had 24 gold medals, 13 silver medals, and 11 bronze medals. And then we have similar information for China and Canada. Okay? Of course, this is actually not real. We're going to just use it to create some charts for visualization purposes. So this is the data frame, very simple, right? And let's try to answer some questions to see what might be the right kind of charts we want to use for a particular kind of purposes. Question 1, if we want to visualize the number of gold medals won by all those 3 countries in one chart, so what chart do you think we should use? I want to quickly be able to tell, say, how many gold medals by South Korea, by China, and by Canada. Focusing only on the gold medal column, what do we do? Which chart? Yes, please. Bar chart, right? So bar chart use bars to represent the count of different values inside the data set. Right? So the height of the bar will be representing how many medals are won by each of the 3 countries. So we can quickly see which country actually won more medals than other countries. So this is the function we're going to use. Px is plotly.express and px.bar just immediately creates the bar chart for us. Okay. Even though it's quite simple, but still, I want to quickly mention the key idea of those charts, even though it's quite basic, but let's still quickly mention it. Okay. So for most of the charts, except maybe pie chart, but for most of the remaining charts, we're going to have something like this, right? So we have the horizontal axis and the vertical axis. I want to be able to tell what is represented by the 2 axes, right? And for the bar chart, as you can imagine, X will be the countries or nations, right? So we need to have a spot for South Korea, and we have to use a spot for China, and we use a spot for Canada, right? And Y will be the count of gold medals. Okay, so right now we focus on gold medals, right? So we want to draw bars to represent how many gold medals is won by each country. Of course, the higher the bar, the more medals is going to be, more medal is won by the corresponding country. Okay, so this is the idea. So as we can see, the key idea is that X will be representing the different countries, in general different categories, but here different countries. Y is count of gold medals, which is in the gold medal column of the data frame. Okay, and with this in mind, we're going to write down the code, right? So what do we do? And we start simple. Let's say I'm gonna get a figure. So I'm saying I'm going to use the px.bar function to create a figure, and I'm going to call the figure fig, F-I-G, or any other names you want to use, right? And I need to specify 3 different things. So let me actually enter the 3 different things across 3 different rows inside the pair of parentheses. Okay. Now, the 3 fundamental thing is that first of all we need a data frame, right? So Plotly usually generate the visualization based on a certain data frame. So it's a DF medals, that's the data frame, right? And then we need to specify X. X will be the countries. So we need to specify the column name for X's, right? So remember we have data frame, the countries and gold medal counts, silver, bronze medal counts. But I think we don't have directly have country, instead we have the nation, right? So let's quickly go back. So it's called nation. The column is called nation. So what's on the axis, x-axis, the horizontal axis will be the nations, South Korea, China, and Canada, right? And what's on the y-axis is going to be one of the remaining 3 columns. Here we want to focus on the gold medal. Remember there's a column called gold, and that gives you the counts of gold medals, right? So the y-axis will be showing you a height of the bar, which is based on how many, what is the value of the gold medal column for the different countries, right? And finally, after completing this part, let's do fig.show. That will show the figure. So this is the basic chart we're going to use, and we're gonna add a few elements to enrich the plot in a few moments, but right now this is how it looks like, right? So I think it actually served the purpose because we have 3 bars, and the height of bar represents the medals won by South Korea, China, and Canada. And horizontal axis is for the nations, vertical axis is for the number of gold medals. So it serves the purpose, but how can we make it look nicer or more informative? So what do you think? What elements may be nice to add? Well, actually we mentioned this last time, right? So we said maybe it's nice to have a title. So let's say inside the px.bar function, let's include title equal to something you want to use. When I typed one quotation mark, it's already suggesting a reasonable title. So let's just use that, or you can use anything else. Okay, so this is going to give us the title. Right? So usually we want to center the title. So in a few moments, we're going to put this title in the center on top of the figure. Okay, but now let's keep it this way. And another thing, let's try to do this. Let's include another option inside px.bar function. Let's say text auto equal to true, and see. Let's see what this gives us. Okay. All right. So if you include text auto equal to true, as we can see, what we have is just the number of gold medals won by each country is included inside each of the bar. I mean, this may not be always necessary, because if you hover your mouse on it, you can already see the number of the counts, the corresponding counts, right? But sometimes this makes it more intuitive. So let's keep it this way for now. So what else do we want to add? Okay. So for example, sometimes you may want to change the label of the axes, right? For example, gold. Because that's just the column name, right? So maybe you want to make it more kind of natural. You can call it gold medal count or something. And the horizontal axis, maybe using country. So a little bit of a customization may be good. And this time we're starting a different function after using the px.bar function to create the bar chart. Right? So after creating the bar chart, if you still want to add something, you can use this function called fig. Fig is the figure we created, right? Fig dot update layout. So we're gonna adding a few elements that is part of the layout. Okay. So what do we do? For example, we can say y-axis underscore title, and that will actually help us specify the name you want to use, the title you want to use for that y-axis. So let me just accept Gemini's hint. So y-axis title, x-axis title, we're going to call it number of gold medals and country. Right? So then we can run it again. And as we can see, the axis titles are different now. It's updated, right? And one thing we can do is that maybe we can control the width and height of the figure, right? So that's often desired, that you want to customize it a little bit. So you can experiment on what is the appropriate width and height to make it somehow look nicer in your notebook. But here I'm just entering some arbitrary numbers. Let's say width is 500, height is 400, and running the command, and this will make the chart a bit smaller, which is, I guess, somehow nice, right? Because previously the bars are kind of very wide. Now it looks more like a better fit on the screen. Okay, but anyways, that's not too important. Okay, and remember we said we want to maybe place the title of the figure in the center. Now it's toward the left side, right? But what if we want to make it appearing in the center, right? So what we can do is to, inside the fig.update layout function, we can do title x. So that's the horizontal position of the title, right? X represents the horizontal axis. So this is controlling the location of the title alongside the x-axis. So you are moving it horizontally. So it's usually a value between 0 and 1. 0 means that it's at the very left, and 1 means that it's at the very right. So want it to be in the center, so 0.5. Right? So that's how you can make it in the center. So run it. It's not that easy to see because the width is actually kind of narrow. So let's make it the width 800 and maybe height is 600. And now we can see maybe slightly more clear that the title is in the middle, right? Now, if there's title X, of course, there can be title Y that controls the title of the figure with respect to its vertical position. And let's say title Y is 0.8. And then what we can see after using this argument is that 0.8 is basically moving it toward the bottom, right? It's lower in the position, so maybe a bit too low. So maybe 0.9. Now it's right on top of the plotting area. So, I mean, if it's, you can also, for Y, you can let it exceed actually 1, so 1.2, as you can see, I guess not, maybe 1. Then it's going to be sort of at the very top of the allowed area in the figure, right? So, I mean, it looks like it's a bit too high up, right? So let's just use 0.885. And again, it's slightly a bit too high, but then this is actually demonstrate the idea, right? So those are the things you can control to make the chart looking a bit nicer. Of course, there's actually many other options available there. You can refer to the documentation of Plotly Express, or maybe just to find out how to control the appearance of the chart by using generative AI. So, but this is actually the basic approach to at least generate a functioning visualization chart for the bar chart. Okay, so that's actually, I believe, is somehow straightforward. Do we have any questions? All right, so question number 2. This time, let's try to think about how should we manage if we want to include the count of silver and bronze medals for the 3 countries in the same chart. Right? Of course, we just did it for the gold medals, but if we focus on the silver medal column, we can produce exactly the same kind of chart, but it's a different chart. The same thing, we can get a bronze medal chart, but what if I want to show all those bars in the same graph, in the same chart? So what do we do? Remember, we had the stacked bar chart and the grouped bar chart. And so this time, we're going to see how we can create those charts if we want to visualize several variables in the same chart. Here, if you consider gold medal count as a variable, and then bronze and silver, there are 2 more variables. How do we have 3 sets of bars in the chart to represent the 3 different types of medal counts? Okay, so let's try to see how can we do it. And this is where it is more convenient to use the long table of the same data set. Okay? There's a function for quickly converting the data set we had earlier to the long table format, but I mean, if you use something called a melt function that came with the data frames, you can serve the purpose. But here, let's actually use a more straightforward method. So this time, let's just load the long table of the same data using plotlyexpress.data.medalsLong, right? Before we used the medals wide, so the table is somehow wider. This time the table will be narrower, and but it's going to be longer. Okay? So how do you think the table will look like if we use the long table? Something longer but narrower. So this is the wide table, right? How do we say have a table of only 3 columns instead of 4 columns here? But we should be able to convey exactly the same information. So what do you think? Actually, let's. It's okay that if we don't have a concrete idea now, but let's just load the long table of the same data to see how it looks like. So this is the long table. Right? It's longer compared to the previous table. You have more rows. It is also narrower, only 3 columns. Before we have 4 columns. But how can this table convey the same information as the previous table? we still have the same, we still have a column called nation, so that's the different countries. We still have 3 different countries. Right? But what's different? Each country is appearing 3 times instead of once. Right? If we look at South Korea, there's one row about South Korea that tells you how many gold medals is earned by the country. Right? So 24 gold medals. Now, gold was a column in the previous table. Now in this table, it's a value, right? There's a column called medal. And then for a row, if you see in the medal column, the value is gold, it means that that row only focuses on the number of gold medals. And for China and Canada, for silver and bronze columns, all the informations are included in this table, but it's the same information as the previous table, right? It just tells you how many medals of each type by different countries. Okay? So this is the long table. So why is the long table helpful for us to create something like a stacked bar chart? Although I think it's not too important, but I think the idea is actually quite interesting. So let me actually quickly show you how Plotly actually treats the long table and convert it into a stacked bar chart. Okay, so let me actually show you this. This is the long table, right? On the left hand side, we have a long table. And let's, for example, start from the first column. So basically, the idea is that we're basically looking at each individual rows instead of columns. Okay? So let's take the first row. South Korea, 24 gold medals. Right? So what we can do is to create a bar for South Korea. And the height of the bar is going to be 24. Right? So the height of the bar is going to be 24. And that's exactly based on the first row. Okay? So that's about the first row. Now, after I have done this for the first row, we're going to move on to the second row. The second row is China, and the information there tells us that China has 10 gold medals. Okay, so I'm gonna draw a bar to represent China's gold medal, which is 10. The height of the bar is 10, and it's for China. So that's why we have a shorter bar, right? Shorter than 24, and the count is actually 10 for China. And that's for the second row. After the second row, we're going to move on to the third row. Canada has 9 gold medals. And let's see how we can do this. It's actually the same idea, right? So this time I'm going to plot a bar for Canada for the position on the horizontal axis that represents Canada. And we're going to have a bar of a height of 9, right? So that's how we can plot the first 3 rows. And then we're going to move on to the fourth row. South Korea, silver 13. So it means that we're going back to the position corresponding to South Korea in the chart. And this time we're going to add a bar that has the height of 13, right? To represent the silver medal count by South Korea. Now moving on to China, 15 silver medals. So for China, we're going to take the information in this row, the 5th row or row index 4, and then 15 is the height, but it's for China, right? And moving on to Canada, silver 12. So for Canada, another bar of height equal to 12, right? And then South Korea, again, bronze 11, so and another bar on top of the previous 2 bars for South Korea, the height is 11. And then another bar for the next record, China, 8 bronze medals. So this box with height of 8 represents China's 8 bronze medals, right? Finally, Canada, the last row, we have 12 medals for Canada for bronze medals, right? So I guess the intuitive idea is that we're just looking at each individual row separately. For each row, we get the count, that turns into the height of the bar, and we plot the bar in the corresponding location that represents a country. Okay? So that's the idea. Of course, we don't really need to worry about how to implement this idea, because we can just make it happen based on a long table. Okay? But it has to be a long table, because as we can see already, we are looking at each individual rows. And for each row, we only want to have one count that turns into one bar. Right? So that's why we need a long table instead of the white table. If you look at the white table, each row has gold, silver, and bronze counts. That's 3 bars at the same time. So it's a little bit too much for the function we're going to use. Okay? So now we have the long table. Let's try to generate the figure. So fig equal to px dot bar, still the bar chart, right? And this time, what we're going to do is not too much different. Okay, so we're gonna do df medals. Did I call it medals long? Yeah, I call it df medals long. It's because it's a different data frame, right? That's the data frame we're going to use. And then what we can do, actually what we need to do is that X is going to be nation column, right? Y is going to be the count column, because that's what we do, right? So it's if you look at the data set, there's a nation column I want to include on the horizontal axis to represent 3 countries. And then the bars will be representing the counts, right? So the y-axis level will be representing counts, okay? So X and Y will be nation and counts, okay? And so let's comment out the color for now, and later on we're gonna add it back, okay? And then the title is number of medals, because we are showing all medals, 1 by each country, okay? So this is, skeleton command for generating the stacked bar chart. And we're going to do fig.show. And later on, we're going to quickly add the same enriching elements to make it look nicer. But right now, let's just to see what happens here. Slightly smaller. So it's a stacked bar chart, right? As you can see, the boxes are stacked on top of each other. They are the same color, because I didn't specify that you should use different colors to represent different metals. Right? So, but the idea is the same. So basically, for South Korea, we have 3 boxes stacking on top of each other to showing the gold, silver, and bronze medals. And same thing for China, same thing for Canada. So it's already there, right? But of course, it's always nice to separate them by color, because for each country we have 3 boxes stacking up, but they are the same color here. I want to say differentiate the different types of metals based on the metal column. So that's why I'm saying that color equal to metal, right? Remember, we do have a column named metal, so it means that we're going to look at the values in the metal. And then there are gold, silver, and bronze. So if you specify that color equal to metal, it means that we're going to use different colors for different values of the records in the metal column. Okay, so let's see how it goes. Now things are much nicer, right? So we have different colors for different metal. If you're wondering which color is for which metal, you can find out on the legend part on the right hand side. Okay, so that's actually going to serve the purpose. Okay, and questions. Now let me very quickly, without too many explanations, let me quickly again use the fig.update layout function, where we set up several extra controls, right? So let's say x-axis title is equal to country, and we can do y-axis title equal to number of medals, right? And width and height, let's do 500, and 400, maybe 600 for 400 for the height and width, right? And title x is equal to 0.5, so I want to center the title for the whole plot, right? So let's try to run the command and to see if it does give us the desired result. Okay, so I think in general it looks quite nice, right? So we have a stacked bar chart, we have the basic elements included. So I would say it's quite informative, and you can hover your mouse to see the more detailed information included by the chart. Okay, questions? Now, let me quickly copy the whole block of code, and this time we're gonna paste it here, but adding one extra option in the first function. Okay? So let's say I keep everything the same, okay? But in the px.bar function, let's change just one thing, which is called bar mode. By default, it's a stacked bar chart, but if we say bar mode equal to group, it will give you the side-by-side bar chart. So the idea is that you are forming groups of the bars instead of directly stacking them up on top of each other, right? So nothing is different, just copy and paste with one extra argument for the first function. And as you can see, it creates a side-by-side bar charts. We have three sets of bars: blue representing gold, red, silver, green, bronze. Right? So if you want, you can make it actually gold color, silver color, and bronze color. By specifying the colors. And later on, we'll have another example that allows us to specify the colors for the different parts of the chart. And it's going to be similar for this chart. So you can later come back to do the exercise of changing the colors of the bars. Right? So far for this example, this bar chart example, that's what I want to cover. Any questions? So hopefully things are clear. Let me know if you have any questions, either right now or during the break. All right, so next question. What if I want to visualize the share of gold medals? Again, focusing only on gold medals. Let's say South Korea, let's say 30% of the gold medal, China 20%, Canada 50%. If we want to produce a visualization to convey this kind of information, what chart do we use? Pie chart, exactly, right, thank you. Because pie chart is always helpful for us to view the share under each different category. Okay, so let's try to implement the pie chart. It's not going to be much different, but let's do it very quickly this time. Okay, so first of all, fig equal to px.py. Okay, and let me actually directly accept the Gemini hints and do some modification if necessary. Okay. Now, as we can see, after accepting the Gemini hints, we have again three options, three actually inputs for the pie chart. Right? px.py is for pie chart. We're very intuitive. And then the first argument will be providing the data frame. And this is almost always the case, right? And pie chart doesn't have actually x and y axes, right? So it's slightly different from other kind of charts. So they don't have x and y axes, but instead you need to provide the values. Okay? So based on which set of values do we determine the share of the counts? Right now, remember the question says we want to figure out the share of gold medals. So the value is equal to gold. It's referring to the gold column of the DF medals, right? And remember, DF medal is the white table, not the long table, right? The white table has a column called gold, followed by silver and bronze. We only focus on the gold, and that's because we want to use the gold medal count to generate the pie chart to show the percentage of gold medals of each country. And the names equal to nation because, as you can imagine, there will be several pieces in the pie chart. Each slice actually represents one country, right? So, but what are the country names? I want to show them in the chart. So the names of the slices in the pie chart is going to be found in the nation column. Again, South Korea, China, and Canada. Okay? So that will give you the basic chart. Let's see how it works. So fig.show. All right, so this is the pie chart. I think it's looking okay, right? So three slices. The biggest slice is South Korea because if you go back to the original data set, they have the most metals in this data set, right? And China and Canada, so 3 slices for 3 different countries. So the idea is pretty straightforward. Now let me just spend hopefully only less than 1 minute to quickly implement things like title and other things, right? Share of gold medals by countries. So that's one thing we can do. And we can go back to fig.update layout, and we can do the height and width control, right? So we can do width, let's say equal to 600, and height, let's say also equal to 600 to make it actually something like a square for the plotting area. Okay. Now one more thing, let's do title x equal to title x equal to 0.5 to center the title. Okay. So this is what we do, right? Just include the width and height of the chart and also try to center the title. So this is actually the pie chart, and not much difference, right? We just see that there's a title centered, and this size is different, but it's not too obvious. So let me actually make it smaller, maybe 400 by 400. And now we see that it's much smaller. Okay, so the order in the data set is South Korea, China, and Canada, right? Following this order, let's specify the different colors of the different slices. So this can be easily done using another argument called color discrete sequence. Let's specify the colors. So South Korea, China, and Canada. South Korea, let's say we're using brown, okay, and China, let's use yellow, and Canada, let's use red. Okay. So consistent with the original order in the data set, we can specify the corresponding color of the different slices in the pie chart. Right? So let's see if it can go through. So now South Korea is brown, China is red, and China is yellow and Canada is red. Okay, so again a simple pie chart, right? Questions? All right, so let me copy this again, and this time I want to make it slightly different, just to show that we can so let me find the right location. So you can read what's in the notebook about the controls to change the format of the charts. But right now, what we're going to do is that we're going to actually copy and paste first, right? And then we're going to, actually I want to demonstrate two things. First of all, what I want to do is that I want to make a donut chart instead of pie chart, which is the same thing, right? But donut has a hole in the middle. So sometimes you may want it to look like a donut instead of a pie, even though I don't think fundamentally there's any difference. But depends on the requirement. So in the px.py function, let's do whole equal to, let's say 0.5, okay? You can use different values. If the whole size is larger, then the whole is bigger, okay? So let's try to see what happens. So it's between 0 and 1. If it's 0.5, then half of the radius region is going to be the whole, right? So it's a donut chart, right? So it's not a pie chart anymore, even though it's not too much different. So that's one thing I want to quickly test out. Okay. Another thing is that this time we want to include another function which is sometimes useful, and this function, let's put it actually following the update layout function. And this time, this function called update traces. It's not update layout, but it's update traces. So let me first type this function and let me explain what the purpose. So layout is basically for the global properties or attributes of the chart, like title, x and y axis, which are considered as global attributes. And traces are for the individual pieces in the chart. For example, we have 3 countries corresponding to 3 slices, right? And each of the slices will be a piece. Now I want to control how do you describe or depict each of the individual pieces. And then let's finish this and you can have a break, okay? So I'm gonna do several things. First of all, text info equal to percent plus value. We'll see what it does, okay? Right now, we see the percentage, right? But now I want to not only show the percentage, but also the value directly. And value means that South Korea has 24 gold medals, so I want to show the 24 number on the chart, right? So that's something you can do. But usually, I guess it's not very common, right? But sometimes it could be nice. And we can do something like text position equal to outside, right? If you look at those 3 percentage numbers, they are inside the pie chart, inside the donut slices, right? So sometimes you want to pull them out, okay, to let the text appearing outside the pie chart. So then you just specify the position of the text. And one last thing, somehow interesting, but somehow useful. So it's called poll, and it's an array of 3 values, right? So we have 3 values because in this chart we have 3 countries, right? We have 3 slices. If you have 4 slices, you have to include 4 values. So let me do 0, 0, and 0.2. Okay. What does it mean? So the first 2 zeros are South Korea and China. It means that I don't do anything special for those 2 slices, right? But for the last slice, I want to pull it out slightly, right? To detach it slightly, to emphasize it, right? So then let's see what it does. No, nothing special, but for the Canada slice, I just kind of pull it down, right, to emphasize that I want to show you the statistics about Canada's gold medal count, right? So that's how it does. I guess if you make the whole equal to 0 or remove this, sometimes this may be looking more familiar, as many people would show pie charts like this, right? To pull out one slice slightly to emphasize the role of that slice. This time, let's start by loading a different data set. And we first load it again from Plotly Express. So it's another toy data set. But I think in terms of a certain type of visualization, how it works, how do we construct them, I think it serves the purpose. So let me do this. So, sorry, not fig, because it's going to be a data frame, right? So the data frame is called, let's say, df tips. And px.data, that's the location where Plotly Express stores the different data sets. And we're going to load the data set called tips. Okay, and then we start by looking at the content of this data. So it's a data set of 244 rows and 7 columns. So the context is that we have, imagine that you are managing a restaurant, right? And then for every group of customers who eat at your restaurant, of course, we will collect money from them. The first column is the total amount of the bill for a certain group of customers. Now the second column is the tip. So how much money you get from them as the tips, as the tip, right? And then the payer. So the sex of the payer, gender of the payer, right? Female or male. So that's the third column. And then the next column shows whether or not there's any smoker in that group. Usually, I guess these days people don't generally allow smoking in a restaurant, but in this data set, we do have some smokers. And then there's a column called day. So that's when the meal actually took place, right? So it's Sunday or Saturday or any of the weekdays. And then the time column tells you whether that bill is for dinner or for lunch or for breakfast, right? And the last column is the size column. That's the group size, right? For example, in the first row, it's a group of 2 customers. They spend a total of $16.99, $16.99, right? And the tip they paid is $1.01, right? And the payer is female. There's no smoker. It's a dinner on Sunday, right? That's the information provided by this data set. Now, there's actually quite a few things we can do on this, based on this data set. We only want to focus on one thing. We want to look at maybe the tip column, right? So we want to see how much people pay as tip in this restaurant. So we have a column of numbers that shows you the tips paid by different groups of customers, and we want to visualize the distribution. So I'm saying that distribution of total bill, but actually let's change it to tips. All right, so we want to visualize the distribution of tips. So which chart do we use? Any idea? Any thoughts? So I want to look at the distribution of this column numbers, right? Some pay more tip, some pay less tip. So I want to get some idea of the distribution of the sample data. So what do we do? And this is where we have the box plot, okay? So let's look at this box plot. And I think I quickly mentioned that before, but just very quickly, let's try to recall the main elements of a box plot, right? So this is what a box plot looks like. Okay? So we have a box in the middle, and we have 2 line segments extends from the top and bottom of the box. Sometimes we have some points, below the lower line segment or above the upper line segment, and those are outliers, right? So let's focus on the box. Usually, there's a horizontal line inside the box. That's the median. Okay, that's the median. And the bottom of the box represents, if you look at the value on the y-axis, usually it represents the 25% percentile, right? So I mean the first quartile, the same thing, right? And then median is of course the 50% percentile or the second quartile, and the top of the box, its position represents the 75% percentile, right? And what does a percentile mean? For example, Q1, the 25% percentile means that in the whole sample data set, 20% of the value is below this level. That's the meaning of the Q1, 25% percentile or first quartile, right? And same thing for medium and also 75% percentile, okay? Now, how do we determine how long those 2 upper and lower line segments should be? And sometimes we call them whiskers extending from the box, okay? It's actually quite easy. So first of all, there's something called IQR. So actually, I forgot to show it here. So the height of the box is called IQR, interquartile range. So that's the distance between the first and third quartile, the height of the box, the same thing, right? So if you know the height of the box, and then the upper whisker should end after you go above for 1.5 times of the interquartile range. Okay? And the lower whisker is the same. You go from the bottom of the box and travel a distance of 1.5 times the height of the box. And that's the location of the lower whisker. Okay? So as you can imagine, a large mass of the probability distribution is concentrated in the box, because between 25 and 75% percentiles, we have a total mass of 50% of all the sample points, right? And then some values are captured further by the upper and the lower whiskers. So if you look at the top of the upper whisker all the way to the bottom of the lower whisker, you capture a majority of the probability mass. Right? Most of the data points will be between those two tipping points, right? And finally, there may be some outliers. Those are extreme values, like less normal values, right? So either below the lower whisk or above the upper whisk. Right? So in any case, this box plot just shows you several pieces of statistics, like the quartiles, median, and 1.5 times going above the third quartile or below the first quartile, right? And the interquartile range. So it allows you to visualize where 50% of the data points are concentrated. It's inside the box, right? And the remaining vast majority of the probability mass or possibilities are between the tips of the two whiskers, and there may be some outliers, right? Anyways, that shows you some idea about the distribution, right? And some descriptions in the slides you can review afterwards. So sometimes we want to show several box plots in the same chart. So basically we have several parts of the data, and as you will see, in our data set, we're going to, based on the day of the week, we'll have different box plots. For example, on Monday, I can have a distribution of tips. On Tuesday, I have another distribution of tips. They are all represented by box plots. Okay? And we put them in the same box. And here in this example, of course, it's actually the month of the year, the temperature distribution of the month of year. As we can see, the highest temperature will be in August in this box plot, right? Because the box and the whisker position is more, is actually higher than other boxes. And the lowest in this plot seems to be the 5th month, which is May. Okay. Anyways, that's just some quick ideas. Let me know if you have any questions. Now we're going to go back to this data set, and what we want to really do is to look at the tip column, and that's a column numbers. I want to produce a box plot to describe the distribution of that column of numbers. Right? So that gives us some idea about how much do people pay in tips, okay, for a particular restaurant. So some descriptive information in a notebook you can review afterwards. But now we're going to produce the box plot, and it's actually quite easy. So the figure is going to be created to use this function called px.box. It's quite easy, right? And as usual, we need to include several pieces of information. So first of all, I need to provide the data frame. So that's the tip data frame we loaded from Plotly Express. And then we need to provide the y-axis. The y-axis is going to be tip. So because we want to show the amount of tip in the box plot, right? So depending on the different positions in the box plot, that will be corresponding to some statistics that describes the amount of tips you pay, right? So on the vertical axis, you will have the amount of tips. Okay? And we can give it a title. Let's call the title distribution of tips. Okay? And for the figure.update layout, let's do the same three things we did as before. So title X, that's going to decide the horizontal location of the title. So let's say 0.5. Right? So I want it to be centered. And then width equal to, let's say 600. And height, any number you want to use. You may need to adjust after seeing it, right? So finally, I want to do fig.show. And we're going to make some adjustments after getting the first box plot. So I think I missed a comma. So I mean, all those inputs should be separated by comma. So this is actually what we get. Right? So I think it's a bit on the wider side. So I think for this chart, let's make it narrower. So width maybe 400, and maybe looks a bit nicer this way. Right? So that's the box plot. As we can see, the majority of, 50% of the situations will be people pay a tip between $2 and a bit less than $4, right? But then, if you want to capture a wider range, capture most of the possibilities, just look at the distance between the ending points of those two whiskers, right? So it's going to be somewhere around maybe $1, a bit less than $1, over all the way upward to somewhere around $6. Right? That's most of the situations, but there are some outliers. So it means that in the data, a few people paid significantly higher than the normal range, represented by the two endpoints of the whiskers. Okay, so that's how it looks like. So this gives us some information about the distribution of tips. Right? Remember, we focused on the tip column of the DF tip data frame. So that's why. And that's why I specified y equal to tip, right? So on the y-axis, I want to show the amount of tip. Okay? If you pay attention, and if you look closely on this chart, right? So you will find that I didn't include anything like the, what does the x-axis represent? Right? That's because I only want to show one box plot for the distribution of one column of data, right? So if we have to describe what does x represent, well, it's going to be just the distribution of the tips, right? However, sometimes, as we mentioned, we do want to include several box plots in the same chart. Right? So how about, even though we only have one column of data, that's the tip amounts, right? How about we separate those tips paid by different groups of customers based on the day of the week. Right? So let's look at, say, Sunday. Okay? And for Sunday, in that data frame, I will filter out all those data points that is corresponding to a meal on Sunday. Right? And then I will look at only those data points that is corresponding to a Sunday. And then I look at the tips for those Sunday meals. And then I can produce a box plot like this. And then I can, let's say I can do the same thing for Monday, right? So I look at all the Monday data points. I look at the tip amounts for all those Monday data points. And then I can produce a box plot for all the meals on Monday. So another box plot in the same chart on Monday. And we can do Tuesday, Wednesday, Thursday, every single day of the week. Okay? So how do we do this? Not too much different from what we did. But can you guess what we're going to add in order to get several box plots representing the different days of the week? Now here it's only one day, right? But if we are going to use several days, so Sunday, Monday, Tuesday, it's like we're using the position on the horizontal axis to represent different days. So we need to specify x, right? So what is x? We don't have x here for now because we focused on one single column of data. But going back, we can say x is equal to day. Day is the name of the column, one column in the data set, right? So x equal to day, it means that we're going to differentiate based on the day of the week. Those are the values in the day column. Okay, so that's the only thing we are going to do, and let's see if it works out nicely. So you can put it anywhere in the argument list, but it's more natural to put it on top of the y argument position, right? So x equal to day. Okay. And that's the only thing we're going to do, and let's see what we can do, what we can have. Now let's make it wider because now we have more box plots in the same chart, so we need it to be wider. All right, so now we have a total of 4 days. So maybe the restaurant is only open for 4 days a week, and there's only 4 days in the day column. So those are all the possible values based on the data set. So Sunday, Saturday, Thursday, Friday, and then we have 4 corresponding box plots. That shows us the distribution, right? And it looks like the distribution at the first glance they're not hugely different, right? But we do see that in terms of the median, right? Sunday is higher, so maybe people pay more tips on Sunday, right? So it could be simply that the meal itself is more expensive on weekends, and so that if they are paying according to a percentage, it's higher, right? And then on Thursday, looks like they are paying a lower tip on average. Okay? So that's just some information we can get from a box plot. Okay? So, and there's another argument I want to quickly show you. So go back to the px.box function. Let's do another argument called points equal to all. And let's see what this argument does. Previously, we only see the outliers, right? If you include points equal to all, then alongside each box plot, we are visualizing all the data points. Right? So every point there is corresponding to a meal. I mean, usually we don't show them in a box plot because it could be too messy, but if you want to see how concentrated are those points in a certain region of the box plot, that may be a good idea, right? So as you can imagine, for the Sunday box plot, right, as we can see, it's quite densely distributed within the range of the box. And there's also a decent accumulation of mass between the two endpoints of the whiskers, but there's nothing much going on outside the outside the range of the whiskers. Okay? So that's what it does for us. Questions? So that's actually one thing we can do to produce somehow, starting from the very basic box plot that considers only one column, and then after using x equal to day, so basically we're separating based on the day of the week into different box plots in the same chart. So what else can we do? So what else do you think we can do? Because if you go back to the original data set, right? So there are other pieces of information we can make use of. For example, how about we separate out female payers and male payers to see who pays more tips? And how about we also want to visualize if smokers or non-smokers pay more in tips? So those are a few other things we can do. And turns out with Plotly, they are not actually very difficult to do. Let's do it one at a time. Okay. So next, let's copy and paste. And again, we're going to add just one more element so that we have a more informative chart. Okay. So Now we're already using the position on the x-axis to show the different box plots for the different days of the week, right? But now, what if I want to separate out the gender, right? So female versus male payers, what do we do? So as hinted by Gemini, we can do this. Color equal to sex. Sex is, again, the column name in the data frame, right? So I already used the x-axis position to differentiate different days. So I cannot use it again, right? But I can use different colors to represent the box plot for different genders. So let's just do this single thing and see how it looks like. Now, one thing being nice is that we still have the different days of the week because we didn't remove x equal to day. But for each day, now I have 2 box plots because we are separating out female pairs and male pairs. Okay? So one thing maybe slightly interesting is that maybe on Sunday it looks like overall female payers are paying less, but on Thursday female payers are paying more. Of course, for now we don't know what's going on there, but those may be some observations interesting to the manager or owner of the restaurant, right? And to make it less messy, let's maybe remove points equal to all, and that's how we can further separate the data out based on genders. Right? Questions? And one more thing, let's also do smokers. And with just one more line of command, we can actually include smokers. So this time we're going to do facet underscore column, and we'll see precisely what this does to the chart. Okay. We can do facet row, but same idea. But right now, let's focus on facet column. COL means column, right? So basically, it means that we're going to split the whole chart, the whole plotting area, into 2 columns. Right? So column 1, we're going to focus on the non-smokers. What means smokers? Let's see how that turns out. And then column 2 will be the other type, maybe non-smokers, if the first column is for smokers. Okay, so just one line of input argument, and we're going to separate out smoker versus non-smokers. And we can make it wider because we are really including more information, so we need a larger plotting area. All right, so now we have non-smokers, because smoker equal to no, for the left, for the first column, right? The whole plotting area, the whole chart is divided into 2 columns. And column 1, non-smokers, column 2, smokers. Right? So that's allowing us to visualize the distribution of the tips paid by diners, right? For this time further based on whether or not they actually smoke, right? So then if you focus on the non-smokers, as we can see, it's again separated out by day of the week, and each day we have 2 genders in terms of the distribution of the tips they pay. Okay, so this is actually something we can do. If you review afterwards, it's actually quite simple, right? So after you include the basic elements, which is the data frame and the representation by X and Y values, all we do is that we need to include another additional argument to specify how to separate out the data based on a certain column, right? So all those arguments, some attributes equal to something, except for points equal to all or title equal to something, usually it's going to be some attribute equal to a certain column, and then we'll separate out the distribution of the data of interest based on the values of the different columns. Okay, questions? All right, so if there's no questions, let's move on to deal with the last, I believe it's the last chart we're going to discuss for today's class. All right, so we're going to load another data set from Plotly and quickly do the last chart. So let's say we have a stock price data from, again, plotly.express. So we're using this command, px.data.stocks, to load the stock price data. Again, a toy data set inside Plotly, just to demonstrate how we can do a certain kind of plot. Okay, so this is the data frame that represents the stock prices. Right? Each row is one time point. If you look carefully, actually there's only one data point for every month. Okay, maybe not every month, but every week. I think. So basically, for each row we have a date, and then we have a total of 6 stocks: like Google, Apple, Amazon, Facebook. I guess it's called Meta now, but it's old data. Netflix and Microsoft. Right? So basically, if you look at a certain row, what you see, let's say the closing price of the stock on the corresponding day, right? So just I guess nothing too surprising. This is how stock price data will look like. So a timestamp here is only 1 point every day, and then the prices of the different stocks. Okay. Now let's also look at a task we're going to complete for this data set. So what chart do we want to use to visualize the trends of stock prices? Right? Because for stocks, most important thing is to see if it's going up or going down, so that you will predict whether or not it's going to buy or sell or something neutral. Okay. So if you want to focus on trend, what chart do we use? Yes, please.
Line chart.
Line chart. Yeah, exactly. So because line charts sort of use lines to connect all those data points. For prices, if you connect all the prices, it shows you if the prices are trending down or trending upwards, right? So this is exactly what we are going to do. So a line chart. And again, in terms of implementation, it's usually quite easy with those high-level libraries, right? So what do? So we're going to do figure equal to px.line. For line chart, it's simply line. And then, as usual, we need to give the name of the data frame, which is stocks. Okay. And want to provide a chart. It's more like a time series chart, right? So the horizontal axis will be the time, the days, and then the vertical axis will be the stock prices, so we can see as we move forward in time how the stock prices changes. So X is going to be the time, but remember here, in the data set, we do have a column which is called date, right? So I want to use X as the date, and Y, of course, is going to be the stock prices, right? But there are 6 stock prices. Of course, you can pick one to plot, or maybe you can pick a few, right? So right now, I can give you I can construct a list. Let's focus on Google, and then Apple. The code is AAPL for Apple, and then Amazon. So this means that we're not only constructing one line chart, but we are combining 3 line charts in the same figure. Okay? So we want to keep track of the prices of Google, Apple, and Amazon. I mean, if you want, you can focus on 1 or 2 of them, or if you want, you can also focus on all of them. Okay, and then let's do a title. Title is equal to stock price trend, something like that. Anything you want to use. Okay. All right. So then, as usual, let's do a fig.update layout. Let's just accept Gemini's suggestion. So that controls the size of the chart by specifying again width and height, and also title x equal to 0.5 means that I want to center the title. And finally, show the figure. All right, so that's a simple chart, right? But it looks like it's a bit too narrow. So let's increase it, maybe 1,000 as the width. A bit too much because I have to scroll horizontally. and this is about right? So that's just to shows us, how stock prices changes over time. And because we specified three columns representing three stocks, right? That's why we have the three different colors representing the three different stocks. Okay? So that's how we can easily construct a line chart, and that's actually pretty much it. Okay, so there's extra controls where, for example, you can do. Let me actually copy and paste into a new cell, but we're going to do roughly the same thing, but maybe just to add a few things. For example, we can do markers equal to true, because we only have lines, right? But sometimes I want to see the points based on which you form the lines, right? So markers equal to true. Sometimes this may be desirable, and Gemini is hinting that I can do color, discrete sequence, red, green, blue. So that's because we have three stock prices, right? We use red for Google, use green for Apple, and blue for Amazon. And if you want, in the next function, update layout, let's quickly do y-axis title equal to price. So horizontal and vertically, the vertical axis represents the stock price level, and x-axis we can say date, right? Because previously it's also date, but I mean sometimes you want to make the first letter capitalized. So here I'm using capitalized first letter, okay? And nothing different. And the plots are going to be quite similar. It's just that we have the markers on the line, right? Each marker representing a point, a record in the data set. Okay, so this is actually largely the same, but I want to quickly show you. This time I already included the code, so don't worry too much about the codes there. You can always get it from Gemini or any other generative AI. But just quickly looking at this, it's another figure.update layout function. And in this function, I'm throwing in several pieces of information so that I can introduce something that is more interactive, right? So what do we introduce? So don't worry too much about the syntax here, but it's basically about x-axis. So we're doing something about the range of x-axis. By default, the plot shows you the whole range of x-axis in the data. Right? Let's say the data is from January 1st of 2018 to December 31st of 2020, and then that's going to be the range of the plot by default. But how about we want to make it customizable based on the need of the user, right? So it's actually x-axis equal to a dictionary, and there are two main elements in the dictionary. One is called the range selector, and we have three buttons, and you look at the elements of under the buttons key, we will have three actually elements, right? The first element, the key idea is that the step is a month. So we're going to actually, by clicking on this button, I'm going to show the chart only for a certain number of months. But how many months? Well, count as 3. So the first row here is going to give us a button. You click that button, you will be able to get 3 months of price data for those 3 stocks. Okay? And it's going to be backwards, so starting from the most recent time point in the data set and going back 3 months. Okay, that's the function of the first button we're going to create. And you can create another button. This time it's actually 6 months backwards from the most recent data points. Right? Step is month. How many months? It's 6 months. Label is 6M, means that you want to select 6 months of most recent price data. Okay, and one more row, one more element. So this time step is year, and you're stepping backward from the most recent timestamp for 1 year, because count is 1. And label, you can do 12M or 1Y. I mean anything that is intuitive, right? All right. So you don't have to steps equal to all because you want to visualize every small step by some kind of marker in the chart, right? So that's anyways, it's not important, but I want to, because it takes a bit time for typing, so I just included it there in the notebook, okay? So that's the range selector button. And then there's a range slider. Just make it visible. It's actually already there, but usually by default it's not visible. So, and then just by doing those kind of things, let's just see how it does that for this, right? It's a bit similar to, I think I mentioned last time, when you search for a stock on Google, it gives you a similar chart, right? So for example, by default it's the same chart, but you click on 3M, and then you only see the price data for the most recent 3 months in the data set. Okay? 6 months and 1 year and everything. Okay. And then there's also the slider. You can, instead of clicking buttons, you can slide to select the range of time for which you want to see the price data, right? And this kind of thing is actually quite useful in terms of developing something like a dashboard, interactive dashboard. Right? Quickly going back. Yeah, so I think I misinterpreted this one. This is actually another button called all. So basically visualize everything, right? So basically you have 3 months, 6 months, 1 year, and all the data. So corresponding to those 4 buttons here.